So I welcome you all to this course Programmable Logic Controllers. For MVOC it is course code 112, but for electronics I hope there is some different code that you kindly get ensured. And whatever the code is, please remember that the contents are going to be completely identical in both of the courses. So you need not to bother and you can concentrate on the topic therefore. You see these programmable logic controllers, many a times it seems to us that this is a very new topic, but you will be very fascinated to know that programmable logic controllers have been there in the electronics community and industrial community some I think 50 years back. It is almost in the year of 70 when Modicon they had actually introduced these programmable logic controllers in the market. Later onwards, Modicon was changed to the name of Schneider Electric, and after Modicon has introduced these programmable logic controllers, there came other giants in the market like Siemens, Allen Bradley, Toshiba, this Mitsubishi. They all came into the market, and definitely the programmable logic controllers nowadays are an indispensable part of any electronic manufacturing, packaging, painting, automobile, every sort of industry. These programmable logic controllers are playing a very havoc, I must say, because these programmable logic controllers are having microprocessors in their heart. They are having a significant computational capability. They are having a significant decision taking capability on the basis of the logic that it gets at its input side, and therefore knowing the programmable logic controllers in a very versified manner will definitely help you to get the best out of it. I do not know whether this is going to help you in getting access to some of the competitive exams like NET or SET, that is there for the students of electronics, but definitely this is going to ensure a very good future for you in your industry career. So I will start with the topic. Let us first see what are the course objectives. The objectives of this course is to introduce you to the general hardware specification of programmable logic controllers and the I/O devices. The next objective is to develop amongst you the concepts of creating the ladder diagram for process control description. That means we suppose that after completion of this course, if a certain process is given to you, you will be able to create ladder diagram out of that. And finally, our final aim is to give you the basic to advanced level software tool concepts for application of PLC in real-time operating conditions. So our basic aim is to make you aware of what a PLC is, what are its hardware specifications, what are the various I/O devices that can be connected to the PLC. We want to develop the concepts of creating ladder diagram from a process control description. Please remember that this is one of the most important topic. Many a times it happens, I have seen that students know that how to program a PLC, how to put it on and off, some inputs, some outputs you want to give to the PLC, and accordingly you want to get the signals out of the PLC. These things are okay, but when it is the time that you are given with some process control description, many of the students they are unable to get a ladder diagram out of it. And here lies the intuition of a programmer. Here lies the intuition of a programmer, which is very much required in order to get the best out of a PLC. Because whenever you are going for the job of a PLC programmer in any of the industry floor, you will not be asked what is a timer, what is a counter. You will be given a task maybe, and that task you are to perform through a programming technique. So here lies your capability of how to design or develop a program when you know the actual physical condition that is going to get over there in the factory floor. Now for this we will be providing you with some basic software tool and advanced software tool in the PLC. I do not know to what extent we will be able to give you the advanced level software tools because they are lying in some of the last modules of your chapter, and if the university decides that exam has to be conducted in the month of March itself, then it will be very hard for us to complete all the issues. Therefore, I urge all of you to be very sincere, to be very adhered to the syllabus, and complete some part of the syllabus most benignly and proactively. And what are the course outcomes? We expect that after completion of this course, you should be able to do the following aspects. Number one, the first thing that I have written, you will be able to create ladder diagram from process control description. Therefore, please remember that in this case, whatever the question paper that will be set for you in your examination, that are not going to be that what is a timer, what is a counter. Situations will be given to you, and accordingly you are to create the ladder programs. So this is going to be a very complex sort of evaluation process. I am not going to be very easy. Okay, I am not going to ask you some of the questions which are of very easy type, that what is the full form of a PLC. I will be given some complex control environment. I will be giving some complex situations, and I will expect that you will be able to get a complete ladder diagram out of this. Then you are to apply the PLC timer and counter functions for real-time applications. Again, you can find that you are here to apply the PLC timer and counter functions. That means questions will never be asked in such a manner that what is a timer and what is a counter, how does an up counter work, or how does an down counter work. Such question will never be there in your question paper, even in your class tests. So whatever questions will be there will be based on applications, and we will always keep an application oriented discussion so that you can very easily set up your mindset in that way only. Then we will be having the PLC for the application of analog signal processing as well as data handling applications. These are advanced applications of the PLC. And finally, the most advanced application, we will be trying to implement PID function with PLCs for process control applications, because nowadays, although the PID controllers that are there in the industry floor, they are all networkable. We can connect it to the, you can connect them to the network, and the same signals can be sent to a central SCADA or a distributed control station, so that the decisions from the PID recordings can be taken by the main unit, the main console, or the SCADA supervision station, or the DCS station, or if there is some remote IO operations, then all these things can be done. But definitely PLCs nowadays, advanced PLCs, they are always fitted, always given with the capacity of getting the PID functions embedded onto them, so that no more you had to use the PID controllers. You can directly use the PLCs for PID functions by themselves. And definitely you know that SCADA screens are nowadays everywhere in the industry, and it will be very easy for you to understand what the operation is taking place at the PLC end if you are controlling some continuous process and batch process, especially in chemical industries, some liquid industries, petrochemical industries, like that. So this is going to be your syllabus outlay. You have got 5 units. In the unit 1, we will be considering introductory concepts as well as programming basics. What I find that the introductory concepts will take a lot bit of time, because definitely I know that you all are very much aware of the PLC platform, you know the programming techniques, but definitely I must come to the level of yours, or we must come to the same level where we can discuss our problems. Therefore, I will be taking a good bit of time with the introductory concepts and the programming basics. And in the unit 1 only, we will know that how to collaborate or how to corroborate these process control descriptions with PLC programming functions. So here you need to be very careful, and if you are not much regular in your lectures, then it will be very tough for you to understand and later onwards to grasp the topics. In unit 2, we will be getting what are the various register functions in a PLC. We will know about timers or counters, which are some inbuilt functions of the PLC. In unit 3, we will be going with some of the advanced operations, which are mathematical operations with the PLC. We will be working with arithmetic operations, number comparison, and then one of the most important concepts like skip and master control relay function with a PLC. In unit 4 we will be working with some data movement control functions like data movement, then jump control, data handling and digital bit operations. And unit 5 we will be working with most advanced functions of PLC like analog operations, PID control, and definitely we will try to put some case studies which will be more assignment based, so that you can brainstorm yourself for several advanced applications, advanced industrial applications where PLCs are connected, and how the PLCs have been working in various sectors that you can work. And now here I will be saying that I will be sharing with you some of the PLC programs which will be almost maybe 100 lines, or in some cases I will be working with 500 lines program also to you, so that you can put your brains on them. We can discuss on the issues, and you can master yourself in programming the PLCs. You see that programming the PLC does not always mean that you can work with timers and counters, you can put some of the inputs on and you are getting some of the outputs. So this thing does not mean that you are good in PLC. A person who is good in PLC programming does come out of the intuition, so that he can read a physical condition and develop a ladder diagram or a sequential functional chart out of that physical condition. So this is most important, and you must consider yourself very fortunate that PLC has been a subject of you in this, because in most of the cases the master syllabus more theoretical subjects are there, but such type of subject like PLC is there, and we have designed a very in-depth syllabus for you, so that you can work comfortably in the industry flow. So this is going to be the bitwise distribution of unit 1. In the introductory concepts we will be getting introduced to the programmable logic controllers. Then we will be talking on the hardware considerations of a PLC. Then we will be talking on the factors to consider while selecting a PLC for a particular application. We will discuss in detail about the input devices and output actuators that you can connect to the PLC. Now, to the best of my belief, both of these courses, that is MBOC Automation and MSc Electronics, both of these courses have industrial instrumentation as a subject. So whenever you study this subject of industrial instrumentation, please remember that whatever transducers or sensors you go through that are electrical in nature, they can be somehow connected to the PLCs. So I will be covering the overview of the subjects, because in the subject of industrial instrumentation you will be covering the things with more detail. Therefore the input devices and output actuators will constitute a very important part of our discussion. Then we will be having this IO processing ideas with a PLC, because IO addressing is one of the important concepts that you should not miss while this PLC course you are undergoing, any PLC course. And the basic jargon comes with the number of manufacturers, because you see, if you go into the market you will find so many manufacturers for PLC, right? So there are Allen Bradley is there, Siemens is there, Delta is there, Omron is there, Mitsubishi is there, Schneider is there, Fatec is there, even Indian PLC company like Renu is there. So all of them they have got some or other notation scheme. So it is not possible for me to get into every notation scheme. Definitely I will be discussing a bit diversely, so that we can work on some of the notation schemes. Maybe I will be talking in some cases about the Mitsubishi, in some cases I will be talking about the Siemens, or in some cases I will be talking about the Bradley schemes. But every time it is not possible for me to cover up all the aspects. Now you will be very fortunate to know that DDUKK, Deen Dayal Upadhyay Kaushal Kendra, in which you have taken admission for your Masters in Vocation program, this is the only institute in Aurangabad which are having number of PLCs under one roof. We are having Siemens PLC, we are having Allen Bradley PLC, we are having Schneider PLC, we are having Delta PLC, and we are having Fatec PLC. So none of the institutes in Aurangabad offer 5 PLCs under one roof, and these 5 PLCs are at your doorstep for your experiments, your work, You can work on them, you can enrich your knowledge with their experimentations by yourself. So unless you do the experimentation by yourself, it is not possible for you to get master with all the notation schemes. So I urge that you take this opportunity to work on these systems. Every time a teacher might not be available to support you, but you please get into the systems, pounce on them, sit with them, put your soil on them, put your this pasina on them, and then you will be mastering this subject like anything. There is no other option, I must tell you. Just going through the topics on the lecture and then mastering the PLC is not possible. I can only give you the ideas. You need to work a lot on this. You need to just take your uh, everything out on these practices. Next, you will be in the very first unit, you will be knowing what is the basic concepts of PLC programming, where we will be working with general PLC programming procedure. We will be knowing how to program the basic IOs, the internal relay concept we will be covering, and definitely the final thing will be creating ladder diagram from process control descriptions, which is going to be one of the most important topic of our discussion. So by this time, are you comfortable with this? So am I properly audible to you? Okay,
Yes, sir.
okay, thank you, thank you. So now we will be getting into this topic in more vivid manner. So first of all, without going into the PLC directly, let us see what are the typical tasks that are confronted in a control system, or what are the tasks that are taken care by a control system. If you look at a control system or look at a vast type of control system, then you will find that there are mainly three tasks that they perform. So what you need to do, you need to look at a number of control systems. Maybe you can think of some industry process, maybe you can think of some household process, maybe you can think of some institutional process, so that you can have an idea, broad idea about a lot of systems that are taking place. So if you look at them in this broader manner and then try to segregate them, you will be finding three basic categories in which a control system is working. In case 1, you will find the system to perform a sequence of events. Sequence of event means that there is a particular job that is being done, and there are job 1 to be performed, then job 2 to be performed, then job 3 to be performed, like that. For example, if I ask somebody of you, you are sitting in front of me, that maybe Mr. Nadeem, I am giving you 100 rupee note. You kindly go to the shop and bring a Cadbury Dairy Milk fruit and nut for me. I am very hungry. So you will be taking the note from me, you will be going to the market, and you will be coming back to give me that chocolate. Now you see that it may so seem apparently that this is a very easy process. But if you consider cautiously, then you will find that your brain is doing several jobs in a very sequential manner, which is not very simple. First of all, you need to take the note from me. You need to understand that this is a 100 rupee note. You need to stand up from your chair. You need to walk a bit. You need to open the door of the classroom. You need to go to the corridor. You need to walk through the corridor. You need to open the door of the corridor. You need to walk through the staircase. You need to come down. On the parking stand, there will be several bikes, amongst which you need to find your own bike. You need to take the key from your pocket. You need to start the ignition on. You need to get into the market. You need to go to shop 1. There you will ask, Cadbury, Dairy Milk, Fruit and Nut, is it there with you? There will be two answers, yes or no. If yes, then you will be saying, I have got 100 rupee, so which item can I take? Or if it is no, then you have to go to another shop. There it may so happen that the item is there, but the particular packet that is available, that is not of 100 rupee. It can be of higher cost than 100 rupee, but you have got only 100 rupee for that I have given you. So you can see that there are several tasks that you are performing in sequential manner, and everywhere you are to put some or other logic, because whenever you are getting out of the classroom, there are two choices for you. One is the left way, other is the right way. Through the left way you will be finding the downstairs, through the right way again you will be finding the stairs to go down. So which path you will choose? So everywhere the logic things comes into action. So therefore, whenever we can find such a type of event, such a type of job, you will find that there are several events that are taking place sequentially, and accordingly you are to perform. In the next example, we will have to see that there are several processes in which we are to maintain some variable constant. If I take the example of our refrigerator, you can see that in refrigerator what is happening. Many a times in the day we open the door, we close the door, we take something out of the refrigerator, we put something into the refrigerator, whatever is the thing. The job of the refrigerator is to keep the temperature constant. Here you can see the temperature is a variable factor, because whenever you open the door of the refrigerator, what happens? That the ambient temperature wants to raise the temperature inside the refrigerator above its maintained level. So under that circumstances, when you close the door, again the compressor has to start itself in order to maintain the fixed temperature for which you have programmed the refrigerator through a regulator. In the third case, you need to follow some prescribed change in a continuously happening process. You need to follow some prescribed change. Let me give you an example. If you are running in a marathon, you know that right from the beginning you are not running at your full speed. You start at a gentle speed. After some point of time that you know, after how much point of time you need to raise your speed a bit, then you are again to slow down your speed, and you know at the last, when the last few laps are remaining, you need to enhance your speed. So this is a particular process in which you are continuously changing the variable with respect to time. So control system can be segregated into these three types. Now we will see three examples. In first case, we will be taking a sequence of events. Here I have tried to give some industrial examples. You can see on the left of you this particular figure. This is actually a conveyor belt through which materials are moving. What we want actually, if the materials which are opaque in nature should go through, and which are transparent in nature should be put in this particular bay. So whatever the materials which are opaque in nature, should go through this way, and which are opaque in transparent in nature, they should come this way. So there is a deflector. Now how this thing takes place? Once you put the conveyor on, after you put the conveyor on, the material will be passed through these photoelectric sensors. So if the material is transparent, then the photoelectric sensors will give a certain sort of signal, and if the material is opaque, then the photoelectric sensors will give a different type of signal. So accordingly, whatever is the signal of this photoelectric sensor, in one case if it is 1 and in other case if it is 0, because we are talking in terms of digital, either it will be 1 or it will be 0. Either the photo will pass through the material or the photo will be stopped through the material. Either this optical line will be cut or the optical line will be maintained. So accordingly, what will happen? The material will go through. Now this is a deflector. This deflector is being acted maybe by a servo motor. So what will happen, that deflector will remain closed when the transparent material is there, and the deflector will be coming in this deferred situation on this I should say deflected situation whenever there is the opaque material. So what will happen, that whenever the opaque material is there, this is the source, this is the detector, the source will be sending the signal, but what will happen, as the material is opaque, the detector will not be able to detect the signal. So this situation will be raising a 0 at the output, and as the output is 0, the deflector will be programmed in such a manner that when the output is 0, the deflector should get deflected. Okay, so deflector will come in this condition, and whatever the material is there, it will be getting collided with the deflector and will come in this situation. So here you can find that there is a sequence of event that is taking place. So this is one of the tasks that are taken care by a control system. Next, you need to maintain a constant variable. Suppose this is a source tank. You have got water held within this tank, and here you have got a valve. Let it be a faucet. Okay. With yes. No problem. You will be getting this screen in the recorded manner soon after the lecture. Okay. So whenever you can find this, there is a vessel and there is a faucet like this, and you can see that there is a clock which is actually keeping track of the time. So what we require here, as you can see in the graph, we need a constant flow. We need a constant flow with respect to time. So under such circumstances, what you need to do, you need to connect some sort of arrangement to this faucet, so that whatever is the change in the load side, or whatever in the change is the change in the source side, the faucet will be maintaining its opening in such a manner that you will be getting a continuous flow. Now, why this is going to change? Let me tell you that if the level of water is getting lowered in this tank, then the water coming out of the faucet will be less in amount. Or in the other hand, if there is too much load on the other side, the source will be getting depleted very fast, and accordingly you will be having less amount of water coming out of this faucet. So what you need to do is you need to maintain some mechanism by which you can control the rotation of the faucet with respect to time, so that your flow is maintained constantly. And in the third way, you can see that I am to program maybe a controller in such a manner that the faucet with respect to time will be letting the flow in this particular fashion. You can see the fashion that I am showing through my pointer. This is a zigzag pattern, maybe for the first few amount of time, for the first certain amount of time it will be maintaining a continuous flow. After that the flow will enhance, then again the flow will be maintained, then the flow will come down. So this is a continuously happening process in which with respect to time you need to maintain a control element in such a manner that it will be continuously changing the faucet in order to keep the flow as per the programmed flow rate. So these are the basic three types of tasks that a control system has to handle. And whenever you are working with a programmable logic controller, rather any controller, you must ensure that such type of work should be doable by the controller. Whatever the industrial controllers or the controllers that are used for very fundamental projects by students, they are capable of handling all these problems. Only you are to make them able in order to accomplish such type of tasks. So I think it is 12 and there is time for another lecture. I will stop here and I will immediately share the video in your group. So tomorrow again I will continue with the rest of the topics. Thank you for now.